So we need to count the number of factors of 210 that are odd numbers that are greater than 1. So the way I did this in exam conditions is I just do the way where you start with the smallest number, 1 and 210, and you write the results of dividing it. So for example, next number that's going to divide 210 is 2. You'll get 105. Then you go to the next one, which is 3, and that's 70. And then 4. 4 times 5 is 20. 50, wait, no, 4 times 5 is, no, 4 doesn't divide. So, yeah, because I should have known, because 10 is not divisible by 4, but 5 is. 5 times 4, that's probably what I was thinking. 5 times 4 is 20, and then 42, and then 6. 6 times 3 is 18, and that works. And then 7 works. So this is kind of the standard method. You list them all out. 8 is not going to divide. 9 also not. And if you do the prime factorization, that will also make things clear, because 9 has 2 3s. Then 10 does. And then not 11, not 12, because that would require 2 2s. 13 prime. 14 is 7 times 2, so we're going to do that, and we'll get 15, and you can see that's 14, so the remaining pieces will give you 15, and then it's just going to flip. So here I have to strike out 1 and then count the ones that are odd. 5, 7, and then 105, 35, 21, 15. So if we list them out, there's a total of 7, which is choice E. So this is kind of what I did in the exam, but now I'm thinking you could go about it by looking at the prime factorizations, 2, 3, 5, and 7. So I have to just exclude the 2, and the question is, with 3, 5, and 7, how many odd numbers I can create by selecting. So if I just select 3 and a 5 and a 7, so that gives me 3. And then I can pair them, 3 with 5, 3 with 7, and 5 with 7. So that's going to give me 3 more. And you can write it like this. So that gives me 3 more. And then finally, selecting all 3, you don't have to compute it. You get 1 more. And so if you notice, now we get 3, 3, and 1. So a 7. So this is, of course, the smarter way to do it. But sometimes in the exam, I kind of know what I need to do. And yes, it might take more time, but sometimes I'll go that route. So because in the exam, you don't really have the luxury to be thinking of all the possible approaches. Now, of course, if this was a really large number, I don't know, 25, 20 or something, then I won't do that. Then I know for sure that I have to go after the prime factorization, or in a way that it's more manageable. And those are the kind of clues in the questions. If I notice this is a small enough number, I'll do the grunt work, even though this is the better approach here. If it's much larger, then I know they want you to think about something else in a smarter way, so that the computational work is reduced. So summarize, the answer is E.